Hi. In our last session, we were discussing about TCP handshake, and we discussed about TCP header, right? So we
Yeah,
like
yes.
source. What is source port? What is destination port? What is sequence number? What is acknowledgement number? What is header length? What is like result field? And different types of TCP flags. What we have. So
Yeah.
6 flags are there. One is like URG flag, and acknowledgement flag, push flag, reset flag, syn flag, and finish flag. Okay, so these are the 6 flags. Like mainly we'll use. There are some other flags as well, but these are the main one. Okay, and like window is nothing but like how much amount of data it can be transferred to the destination at single point of time. Okay, check some urgent pointer options. We discussed about I can say TCP header and
Whenever we need
TCP
to push
handshake.
this. Yeah,
Yeah.
yes.
So now and next topic is IP header. Okay, so from the application layer, if you remember, from the application layer, presentation layer, session
Session
layer,
layer, transit,
transport
transport
layer,
layer,
network layer, right?
yeah, network
So
layer,
in the application layer,
data
we
link
discussed
layer,
about
physical layer.
yeah. So in the application layer, we discussed about what I can say, different protocols like FTP, TFTP, Telnet, all these things we discussed in the application layer. Okay, so in case of presentation layer, nothing was there. Okay, so in case of transport layer, nothing is there. Like with respect to protocols I'm mentioning here. Okay, so when it
Yeah,
comes
yes.
to transport layer, we have two protocols in transport layer, that is TCP and UDP protocols,
TCP.
and TCP header is there. Okay,
Okay.
so we discussed about that in the last session. Now next layer is network layer, right?
Network
So
layer.
in the network layer, what will have you, what can be done in the OSI layer? IP addresses will be added, right? About source and destination. So we can say in the network layer, we have the IP addresses.
Yeah, yes.
Okay.
With respect to the port.
Yeah, the port will be added in the transport layer itself.
Yeah, yes, yes.
TCP and UDP, so it's related to ports only.
Yeah, okay.
Okay, and the network layer, it's only adds the IP addresses.
Yeah,
However, while
yes.
coming to the like from OSI layer, transport layer, source and destination port will be there, and data will be there, and here it's add the source and destination IP address only.
Yeah, okay.
Okay, so like so IP header, in the sense like the IP address will be there, right? So like in an IP address, like what other things will be there? Okay, so in the IP header, see, source and destination IP is just small part. Okay, even in the
Okay.
TCP header, if you remember, okay, I will be having mainly source port and destination port. Okay, along with that, we are having like a number of things, right? If you observe here, mainly source port and destination port only, but this all things will cover, it will be required for some reason. So we discussed about those things. In the
Okay.
similar fashion, in the IP header also, we need source IP and destination IP address only, but these details are required for some reason. Okay, so let's
Okay.
discuss
Here we
about
will call in
tell me
network layer, we will call as packets, right?
on packets. Yes, in the
Okay.
like session,
Transport layer, we will call segments.
exactly, because like
Okay.
a one piece will be divided into multiple pieces, right? If you so like the data can be divided into, this is the
Yeah,
data, and
single
it
line
can be
segment
divided into multiple
into,
pieces, na? So each piece called
yes,
a segment in the
segment.
transport layer. Okay, in case of network layer, this called as a packets.
Packet.
Okay, so here we are having like what is version, what is IHL in like internet header length. Okay, what is DSCP, what is
Okay.
ECN, what is the length actually here. Okay, so we'll discuss about one by one.
Okay.
So version. So version in the sense, first feature is version, right? If we observe, okay, so these bits are representing, here we have from 0 to 31. So total 32 bits in length here, right? So for each one, like 16 bits. Suppose if we can see for version, how many bits? 0 to 3. It means 4 bits, right? So here for IHL,
Okay.
4 bits. Okay.
Mhm.
For DSCP, it is around I can say 6 bits. 1, 2,
Okay.
3, 4, 5, 6 bits. Okay. For ECN,
Where
2
it is?
bits.
In the page it will be appear or what?
Sorry.
In the presentation, is there anything that DHCP?
DSCP, not DHCP.
Yeah,
Yeah,
okay.
it will be there. So everything we'll discuss actually. So I'm telling you,
Okay, okay.
like how the bits are calculated.
Uh-huh.
So here, if you can see, like I'm mentioning, version is 4 bits. How it is
Mm-hmm.
4 bits? Because this is how they
0
have
to 3.
segregated.
Okay.
Okay. So when it comes to version, it is in 4-bit length. Okay,
Mhm.
and it specify the version of IP header. So in versions, like we have 2 versions of IP now. That is IPv4 and IPv6.
PV6.
So like IPv4 IPs are depletion is going on. That's why we have IPv6 coming into the picture. Okay, so which version of
Okay.
IP we are using, either IPv4 or IPv6? Okay, so if it is
Okay.
IPv4, like the data here is there. No, here in place of this one, 0100 will be added. In case of
Mm-hmm.
IPv4, in case of version 6, 0110 will be added.
Okay.
Okay, that is about version.
Mhm.
And next one is internet header length. This is also like a,
Here, I think the presentation is passed.
is it?
The Yeah,
Okay, 1 second. From when it is? From now or from long time?
from long time. Like it is in still 82.
82. Oh, I was discussing about these things actually. For some reason, I don't know. Now,
Yeah,
able to
yes, I
see now?
can. Yes, yes.
Okay, okay, cool. Like, so we were discussing about IP header. Okay, so here we are having, like, what is, this is the IP header diagram. Okay, so here,
Okay.
we'll be having mainly IP addresses, source IP, destination IP addresses. Apart from source IP and destination IP, we'll be having some other things also. Okay, that is
Okay.
version, IHL will discuss about all these things. Okay,
Okay.
so when it comes to, like here I'm defining, how much bit it is, the version. Okay,
Uh-huh.
how much,
Yeah.
like data is it, like, internet header length header stuff. Okay, all these things we'll discuss. So here, whatever the
Okay.
data I'm mentioning in 4 bits, 6 bits, all these things, it has taken from this diagram.
Okay.
So 0 to 32 bits is there in length for each single thing. Okay, so we have to see how much it is. Okay,
Okay.
so for version, okay, version here, like it's a size of 4-bit size it is. Okay, so version is a
Okay.
4-bit size. So here, it will tell, whether it is IPv4 address or IPv6 address.
Okay.
Okay, so if it is IPv4 address, okay, so
Mhm.
here, in place of version, 0100 will be there. In case of
Mhm.
IPv6, 0110. So if you convert these into, like a decimal format, 0100 is a 4, 0110 is a 6. If you
Okay.
convert, so we have this one, no, like 84210 something it is there, no. So if you can say like a 0100, right?
Yeah.
0100, it means 4. Okay, so 6 means 0110. So here it will be sum actually, if you can, like in the
Mhm.
conversion. So if it is a version of IPv4 0100 and version 6, it is
Mhm.
IP v6, that is 0110. So what, this is the
Okay.
version. And internet header length is what is the length of full IPv4 header? Okay, so the minimum IPv4 header is 20 bytes and maximum is 60 bytes.
Okay.
Okay, so it is also in 4 bits length. And next one is DSCP. So here we have DSCP, right? So how many bits it is? 6 bits, na? 3, 4, 5, 6. So
6,
DSCP 6 bits it is.
6 weeks.
Like, what is DSCP? DSCP stands for Differentiated Services Code
That
Point.
is good point.
Okay, so what it will tell? It will use it for QoS. This is quality of system. Okay, so like, so
Okay.
if you want to remember what the functionality of DSAP means, okay, it is used to prioritize the delay sensitive data. It means, so if the traffic is, like voice or any video stream, okay, suppose, like if you're presenting something, if there's delay also fine, they can be able to see your screen. Okay, but if you're speaking something and the receiver got delayed your voice,
Okay.
so it won't be good, right? So there is a
Yes.
like delay in the communication between you and, the receiver. So like at the
Mhm.
point of time, like of streaming voice and video streams, okay, so this DSCP will be used to prioritize the sensitive data.
Okay.
Okay, so like in general we won't do all these things, okay, like in manual, but on the back end these all things will going on.
Yeah. Okay.
Okay, that's what we need to remember. And next one is
Okay.
ECN. So here, ECN stands for explicit conjunction notification. Suppose, in the between source and destination, okay, like this is the source, this is the destination, okay. But many devices will go through this channel, right, between the network device. It's not only you, many people are connected, okay. So here, if congestion is happening, congestion means like if high traffic is going on through this channel, okay, so it will protect, without dropping the packets. Okay, so packets,
Okay.
whatever you are sending from source to destination, though conjunction is there, ECN will be help us to do not drop the packet in the transmission. It will make
Okay.
sure to reach the destination.
Destination.
Okay, that is about ECN. And now we have total length. So here we discussed, right? So we discussed about what is the version, what is IHL, what is DSFN, what is ECN. Next one is total
Okay.
length.
Total
So
length.
here total length is nothing but IP header length plus TCP header length. Okay, that is called a total length. That is in 16-bit size. Okay, so here we have 32 bits. Among them, 16 bits related to these things and 16 bits related to total length. So here total length is nothing but IPv4 header length plus TCP header length. Okay, and the minimum
Okay.
size of that IP diagram is 20 bytes and maximum is 6535 bytes. Okay, and next one
Okay.
is identification. So identification, why identification coming into the picture? So here, suppose you are transmitting, 1 second, where is my pen? Yeah. So here you are transmitting the data between source and destination. Okay. So here, the amount of data it can be transferred one point of time. This is called window, right? In the transport layer, we discussed about that. Okay.
Yes.
And if the data size is more, suppose it has to send some, some 2000 bytes of data. Okay, but it has the capability only some 750 only, suppose consider like that, 750.
Okay.
Then what it has to do, it has to send one time, second time and third time, right? Okay,
Yeah.
so so this is process, called as fragmentation. So it's also kind of segmentation we discussed, no, dividing the packet into multiple things. That is in a similar fashion.
Yes.
We have one more thing called as fragmentation. Okay, if the packet is
Mm-hmm.
fragmented due to large size, okay, so the packet size is large, then what it will do, they will cut the packet into small pieces. That is called fragmentation, and these fragments will be transferred at one at a time. Okay, and here we have one thing called uh, MTU, that is maximum transfer unit. So only one time 1500 bytes of data only can be sent. Okay, this is called MTU.
Okay.
And if whatever the data you are sending, which is more than 1500 bytes, then fragmentation will happen.
Mhm.
It's a kind of segmentation only, what we discussed. No, it's a kind of
Yes.
segmentation only, but depends on the size it happens here. Okay,
Mhm.
and these fragments will be reassembled on the destination host. Okay, that is about identification. And here, so if you want to perform fragmentation or not, that is based on the flags here. Okay, if the data is more than below 1500, okay,
Mhm.
like the data will be, it's not fragmented, right? So in that cases, bit one
Yes.
will be used. If the data is
Mhm.
more than 1500 bytes, then in the flags,
Bit two
bit 2
will
will
be.
be selected.
Yes.
Okay,
Yeah. Yes.
so that is up in here, bit 0, like it will be reserved and it's always set to 0 only.
By
That is
default, it
about,
is.
by default it is 0.
Okay.
Okay, and next one is fragment offset. So here we were discussing like what is fragmentation, right? So
Yeah.
what fragment offset will do, it will tell the position of the fragment. Okay, suppose this is
Okay.
the data, like the data can be divided into multiple fragments. Okay, so here 1 2 3 will be there, no, while receiving
Mhm.
there is no guarantee that one is receiving first, 2 3, so there will
Mhm.
mixing matches, first 3 is received, then 2, then 1. So what
Mhm.
this offset will do, it will reassemble the data based on the fragment offset.
Okay.
Okay, so it allows the fragments to be reassembled even if the fragments received in the out of order. Okay, that is what like fragment offset means, and I know how it helps. And
Okay.
one more thing, we have time to live. Time to live in the sense,
Like
like we
same
can
as
call
demultiplexing, like.
exactly. No,
Yeah, okay.
multiplexing and demultiplexing is different. See,
In
multiplexing, what it
segmentation,
is
there are
happening, multiplexing, uh, multiple data streams will be transferred into one single stream. Okay,
okay,
and this is called multiplexing, and one to many it is demultiplexing. But
okay,
here segmentation is happening, na? Segmentation and reassembling.
okay,
Segmentation, dividing the packet into multiple pitches is called segmentation, and reassembling
uh-huh,
means based on the sequence number, it is reassembling the data.
okay, okay,
So it is, which is similar to the segmentation reassembling process.
okay,
Okay, and we have next one is time to live. So this time to live is nothing but like a TTL value we can call it as. Okay, so what is TTL value?
real,
I'll show you. TTL is nothing. Let me go to this theory. Okay, so
okay,
TTL is nothing but like suppose you have the source and you have the destination. Okay, so if you
okay,
want to reach between this source and destination, there will be many routers. Okay,
yeah,
so it has to go here, reach this one, na. So by
yeah,
default, the TTL value is 64. Okay,
okay,
so if your packet want to reach till here, okay, 64. Once it reaches the like this router 63, this TTL value will be decreased by one. Okay,
okay,
next if it is reached 62,
52,
next 61, next 60, like that till 64 hubs will be able to configure in general.
okay,
Okay, but like it is by default it is available, but in the mostly if you can see only 30 hops only between the source and destination.
mhm,
Okay,
okay,
so that is called like a TTL value. Okay, and we have the
okay,
protocol. Protocol is nothing but which like their TCP or UDP protocol is there, no?
mhm,
Like in the transport layer. So which protocol it is using? TCP, UDP, ICMP, which protocol it is? Okay. So here
okay,
TCP by default 6 protocol number, UDP we know, and we discussed about ICMP also. We discussed about these three things already in the earlier classes. And
mhm,
OSPF is one of the dynamic routing protocol. Okay, so we'll discuss about
okay,
like about this dynamic routing protocol in the later on classes, but it just shows which protocol it is used. So that is
okay,
protocol. Okay, so till here we discussed. Okay,
mm,
so what is version, what is IHL, what is DSCP, and what is ECN, and what is the total length, what is the identification, what is the flags, fragment offset we discussed, and time to live we discussed. Next one protocol also we discussed. Okay, next one is header checksum. This header checksum, what it will do, it makes sure that the things in the header, it is like there is no errors in the header side, that's it. Okay, so checksum is nothing but like it is used to check if any errors are there in the IPv4 headers. Okay,
okay,
that is the functionality of checksum. Even if you observed like what I can say in the TCP header also. Okay, where it is, yeah, if you can see we have the checksum here also, right? So the
yeah,
checksum is nothing but it is used to check TCP header is okay or not here.
working or
So in
not,
the similar way, it means that there should not be any errors. Okay, so in the similar fashion in the IP header also, header checksum is nothing but they should, I mean, it will make sure that there won't be any errors. Okay,
okay,
and the source IP and destination IP address. Source IP is 32 bits and destination IP also 32 bits.
mm,
So this is about like IPv4 header.
yeah,
Okay, clear? Any
yes,
doubts?
yeah, clear, clear,
Okay. Yeah. So in next session, like we'll go with like what is router, okay, and how what
okay,
are all the vendors we have, like what are the router classification, okay, and what are the internal components of the router, and if we reboot the router, like what are the steps it follows, and like what are the modes of the router, like we'll go ahead further on the router.
yeah,
Okay,
okay,
so router is the device which is available in the network layer only. So because it
yeah,
works
okay,
based on the IP addresses.
okay,
Okay. So after router, like so once we assigning any IP addresses, like what are the rules we need to follow? Okay,
mhm,
and what is routing? Different types of routing we have. Okay, so we'll discuss about like everything, dynamic routing protocol, like once dynamic routing protocol is done, then we'll discuss about WAN connections will be there. Okay. Once WAN connections finished, and then we have different kinds of ACL, that is access control list. Okay. So then we have different types of NAT available. Okay. Once this and all done, then we'll go ahead with the firewall concepts. There are many things to discuss in the basics itself.
Yeah, okay. Mhm.
Okay. So
Yeah,
today we just discussed about IPv4 header, and in the next session we'll discuss about what I can say. From router we'll discuss about what is router, and what are the internal components is there in the router, and what are the modes of the router. All these things we'll discuss from the next session.
okay.